Good afternoon, everyone. Today, we are going to present on recycled waste aggregate concrete. Next. So here we took the references from the recycled concrete aggregates and their influence on concrete properties by Indian Institute of Technology Madras, University of Cape Town. Experimental investigation on recycled aggregate with laboratory concrete waste by VIT University. Next. So let me introduce you to the recycled waste aggregate concrete. What does it really mean? The recycled concrete aggregate is a term used to describe the material produced from cross construction and demolition waste, primarily consisting of concrete, but also including aggregate materials such as sand, gravel, slag, and crushed stones. Recycled aggregates are not only classified as recycled concrete aggregates when the primary material is concrete. By crushing and compressing existing waste concrete and combining it with aggregate, producers can create concrete aggregate to a specific size and quality, which makes it very cost effective to purchase. Next. So what are the objectives of recycled waste aggregate concrete? First one being the sustainable construction practices. Environmental sustainability includes various factors like reduce in landfill use. By using construction and demolition waste as recycled aggregate, the amount of waste sent to landfills is reduced. The next one being the conservation of natural resources. It reduces the demand for virgin aggregate materials such as gravel and sand, thereby preserving the natural resources. Lower carbon footprint. Recycled concrete produces lower carbon emissions compared to manufacturing new concrete from the virgin materials. It also helps in the technological and engineering development, improving the material properties, research and development aimed at enhancing the quality and performance characteristics of recycled aggregate concrete, such as strength, durability, and workability. Innovation in construction practices. It encourages the development of new techniques and practices for production, handling, and use of recycled aggregates in concrete. Adaptation and resilience, enhancing the ability of recycled aggregate concrete to perform under various environmental conditions and loads, contributing to more resilient infrastructure. Next. So what is the composition of recycled waste aggregate concrete? The recycled waste aggregate concrete is made from the recycled waste aggregates, the first one being the crushed concrete. This is derived from demolished concrete structures, including buildings, roads, bridges. After being processed, these crushed materials can replace natural coarse aggregates in new concrete. Second is crushed masonry. In some mixes, aggregates from masonry waste like bricks, tiles are used. These are generally softer and more porous than concrete aggregate. Cement. Cement is consisting of Portland cement, mostly used as a binder. Along with that, it also uses supplementary cementitious materials known as SCMs, which include fly ash, slag, silica fume, which are added to enhance the property of concrete and contribute to sustainability. It's also made up of water. Essential for hydration of cement, water makes up a significant portion of the concrete volume, and it also includes fine aggregates which provide volume and help in reducing the voids in the aggregate mix. Next. So now we are going to discuss the manufacturing process of the recycled waste aggregate concrete. First, collection and sorting. So the waste aggregate is collected from demolition sites and construction areas, infrastructures, etc. Crushing and screening. Crushing the sorted concrete and masonry to desired sizes are done. This typically involves using crushing machines such as jaw crushers, impact crushers, and cone crushers. Screening of these crushed materials are done so as to classify them into different aggregate size. Additional processes like air separation and washing may be used to remove finer particles and impurities. Next is mixing. In this process, the thoroughly mixing of the components in the concrete mixture is done to ensure uniform distribution of materials. Depending on the consistency required, additional water or admixtures may be added during the mixing process. Next is compacting and finishing. Now the concrete which has been made is poured into designated forms at the site. Methods of pumping, pouring, and spreading are being used. And the concrete has been compacted to remove the air pockets and ensure that it feeds all corners of the formwork. Common methods include using vibrators. The last and most important step of manufacturing is curing. This allows the concrete to set and gain strength. Curing involves maintaining adequate amount of moisture and temperature conditions to support the continuing hydration of cement. Now, I would like to hand over the next slides to Biswajit. Thank you.
Thank you, Prachi. We will now proceed with RCA, recycled concrete aggregate. This material is derived from the demolished concrete substitute. It is a eco-friendly material used as substitute of natural aggregate. Here the main problem is the adhere motor. It increases the water absorption by aggregates, lowers the aggregate motor bond strength, that leads to poor structural performance and durability. Here the solution is the surface modification. We provide coating with polyvinyl alcohol, water glass, sodium silicates or cement slurry. This treatment can reduce porosity, increase the strength of ITZ between ICA and new motor. We can remove the adhere motor by different methods like mechanical method, which involves crushing, rubbing, scrubbing, and also we can do with washing also by proceed by soaking in chemical solutions like S2SO4, SCl, S3PO4. Most effective beneficiation involves thermomechanical processes combining conventional or microwave heating with crushing, scrubbing, or rubbing. Then, workability. Workability is the essential property of the concrete from which we know the concrete is suitable for the infrastructure building or not. Different tests are conducted to know the workability of the concrete. Out of this test, slump test is one of those. In this graph, we observe a bar chart where in x-axis there is written percentage of RA. Here the percentage of RA signifies the percentage of recycled aggregate present in the concrete. That is called percentage of RA. Here in the y-axis consists of height and the three colors are present: purple, yellow, and pink. The purple, yellow, and pink signifies the three different water cement ratios: 0.4, 0.5, and 0.6. Then tensile strength. Here in the y-axis we observe that is written splitting tensile strength. Splitting tensile strength is the measure of how much stress a concrete mix can withstand before it splits or cracks. And in the x-axis we observe that is written OPC, FA, FBS. Here the OPC signifies ordinary Portland cement, BFS signifies blast furnace slag, and FA signifies fly ash. Here the two colors are present like purple and yellow, and the purple color signifies the natural aggregate and the yellow color signifies recycled concrete aggregate. Move towards the compressive strength. Compressive strength concrete is a great at handling compression but weak in tension. A tensile test helps predict how much stress concrete can withstand or handle before cracking. So the compressive test is conducted on concretes. In the x-axis, we observe the RCA RA00, RA025, that the numbers are signifies the percentage of RA present in the normal aggregates. And the three colors are represent like purple, yellow, and pink. And the purple color signifies the strength of the compressive strength of the concrete after 7 days. Yellow color signifies the compressive strength of the cement after the 14 days as on 28 days. I will invite Sahil to proceed with physical properties of the RCA.
Thank you, Biswajit. So let's start with physical properties. So there are basically four parameters from which we define physical properties. First is bulk specific gravity, bulk density, absorption, and crushing value. So we have a table here sowing 3 times, that is first day, third day, and 28th day, taking coarse, medium, and fine aggregate. The table shows that the bulk specific gravity is highest for coarse aggregate for all the 3 days. For bulk density, also coarse aggregate has the highest value for all the 3 days. But in the case of absorption, the highest is for fine aggregate for all the 3 days. Next. Now we'll talk about advantages of using RCA. There are several advantages. First is environmental sustainability. One of the most significant benefit of it is positive impact on the environment. Recycling waste material reduces the burden on landfill and minimizes the need for acquiring natural aggregate, which helps conserve natural resources and reduces energy consumption and greenhouse gas emission associated with extraction and transportation of virgin material. Cost saving. Incorporating recycled aggregate can lead to cost saving in construction projects as they are often cheaper than virgin aggregate due to lower processing and transportation costs. Waste reductions. Recycling waste aggregate reduces the volume of waste going to landfill, thereby addressing the issue of waste management and promoting a more circular economy. Improved durability. While the properties of recycled aggregate concrete may vary depending on the quality of recycled material, property processed and selected recycled aggregate can provide comparable or even improved durability and performance compared to conventional concrete. Next. Now let's talk about disadvantages of using RCA. First is variable quality. Recycled aggregate can vary significantly in quality depending on the source and processing methods. Inconsistent properties may lead to variation in strength, durability, and workability of the concrete, potentially affecting overall performance and longevity of the structure. Lower strength and increased porosity and absorption. Recycled aggregate often have higher porosity and absorption rate than virgin aggregate due to presence of old mortar adhered to the surface. This can lead to increased water absorption and a reduced resistance to freeze-thaw cycle, potentially compromising the durability of concrete in harsh environmental conditions. Limited supply and availability. The availability of high quality recycled aggregate may be limited to certain reasons or during specific time, depending on factors such as availability of demolition waste and the capacity of recycling facilities. This can constrain the use of recycled waste aggregate concrete in some construction projects. Next. Now let's talk about where we can use this RCA. There are several places where we can use this concrete. First is road construction, then noise barrier construction, structural fill, pipe bedding and drainage, asphalt pavements. Next. So in conclusion, recycled waste aggregate concrete presents both opportunities and challenges in construction industry. While it offers compelling benefits such as environment sustainability, waste reduction, and cost saving, it also comes up with considerations regarding quality, performance, and regulatory compliance. The adoption of recycled aggregate waste concrete requires careful evaluation of source material, processing method, and mix design to ensure consistent quality and performance. Despite the challenges, advancement in technology, research, and industry standards are continually improving the viability and acceptance of recycled waste aggregate concrete in construction projects. Ultimately, the successful implementation of recycled waste aggregate concrete relies on collaboration among stakeholders, including government agencies, developers, contractors, and material suppliers to address technical, regulatory, and market barriers. By leveraging innovation, best practices, and commitment to sustainable development, recycled waste aggregate concrete can play a significant role in promoting more circular economy and achieving the goal of a greener, more resilient built environment. Next. So thank you everyone for being patient listeners. Thank you.